IETF meeting, so it would be good to include those folks in the conversation. If you've never been a Jabber scribe before, the responsibility is you tune into the working group Jabber room, and if somebody posts a question, usually prefaced by the string Mike, you just get up to the microphone and read it. So it's an easy way to contribute, low responsibility. Thank you, Rich. Dave Lawrence is taking minutes. He's not active in this working group. He does not know people's names. Please take the time to identify yourself if you get up to the microphone so Dave knows who you are, for the record. Really like to have a second note taker. If somebody would like to volunteer, it's not really that hard. Just jot down the major bullets of discussion. You don't have to copy the slides down. Good to have a backup, just in case Dave has an aneurysm or something. Somebody, note taker, please. Please. Boy, suddenly everybody's computers got really interesting. Thank you, Michael. If I what? If I take your what? When do they meet? Let me check my calendar. If I can do it, I will. Yes. Happy to. Okay, so this is an IETF meeting. Statements covered in this room are under the auspices of the Note Well here. Everybody should be familiar with this. If this is your first time at the IETF, you should know that anything that you say here at the IETF meeting is considered a contribution, and IETF IPR policies apply. So this is the TAPS working group, Transport Services. My name is Aaron Falk. I'm the chair. First order of business. We have a co-chair whose name I can't pronounce properly, so he's willing to go by Zahed, which is good for me. So please welcome Zahed. Thank you for helping. A little bit about Zahed and the 3 truths and a lie. You have to pick out which one is the lie. Zahed's written a number of drafts in RMCAT. He's active in WebRTC and congestion control related working groups. He works for Ericsson Research, and he breeds eagles for fun. So you can have to talk to him after the meeting about which one is true, which is false. Thank you. So today's agenda, very briefly, we're going to talk about the documents that are in flight. We've got this document 1A, which is the evolution of the sort of feature derivation of transport protocols. Sort of adding a mechanical process to that, which Naeem is going to talk about. Gori has extended that process or applied that process to UDP and UDP Lite, and it wasn't until I read that document that I really saw how powerful this mechanism was in taking us from this very rich tutorial-based text document, which is the first draft IETF TAPS transports, to something that could feed into an API development. So I think this is really going in a very good direction. We've got some questions here, which I'm expecting the presenters to raise. These are included in the agenda so that you've got some idea of the kind of discussion we'd like to have. Next slide. Thank you. Then Stein's going to talk about the MinSet draft, which we've reviewed here before. It's made some progress. This is really the starting to think about the next phase for the working group of going from just identifying the various features in the protocols to identifying the set that we want to include in TAPS mechanisms. And then finally, Michael's going to talk about the NEAT project, which is an EU-funded project that's doing an implementation of a TAPS-like thing. I can't say they're implementing TAPS because TAPS doesn't exist yet, but as you may have noticed, much of the authorship activity that's coming in the working group is coming from people involved in NEAT, so this is great. Next slide. So This is, I have two very short status slides. As we've already covered, we have a new co-chair, which is great. Because Zayed has a expertise and interest in WebRTC, I'm hoping that his participation in the working group will help to keep the focus on having TAPS work generate something useful for applications developers. I think the applications perspective, we really had to struggle to keep that in the conversation here. So I hope that we'll see some more discussion on the mailing list from that. Draft TAPS transports is up to Rev 10. We finished working group last call. I've been kind of sitting on it because I wanted to see what was going on with the other drafts before sending it to Spencer, but I think that it doesn't need additional revision before it can go to area director review, which is the beginning of the publication request process. It's very likely that between AD review, IETF review, IESG review, RC editor processing, that the document will need to be revised, and so there may be some discussion in the group to support that. But that's looking really good. So I had a personal question about, a process question which I discussed with Spencer about whether it, because TAPS is still kind of finding its way on what the output's going to be, whether we might want to just park this document rather than publish it in case we discover later that, oh, well, we need to sort of go back to the beginning and repeat the process with some slightly changed scope. But with a little bit of reflection, my position is that I think we should just go ahead and publish this. If we have to publish a BIS or something, I don't think that's the end of the world. I think it's kind of unlikely given the amount of thought that's gone into this document. So I'll actually pause here if anybody has a comment about that, like the authors or editors. Do you?
Yeah, could have been. In the name of Spencer, I can probably say that it's to the working group to decide that. Definitely.
About the acoustics in the room, yeah, I can't understand a word you're saying.
Okay. What do we do here? In the name of Spencer, it's probably to the working group to decide that. Yeah, I mean, like to delay the protocol or not. I don't think that Spencer will have an opinion on this, and I'm here on behalf of him. So yes, and as an author of the document, I think it's ready because it's a base document documenting what's out of there. I don't think that anything we will do in TAPS will change the protocols we've documented there, so I don't see a reason to wait.
Okay, cool. Just trying to be transparent here. Like I said, Gory's draft on UDP and UDP Lite applies the mechanisms from the draft IETF TAPS transport usage to these other protocols. So I think a bunch of useful stuff falls out of that. I think that really we'll talk about that in the spot of the agenda. Gory is now actually in Dispatch, the art area, apps area working group, trying to solicit some review of UDP of this document to make sure that he's captured the useful aspects of how UDP and UDP Lite are used by applications. But he'll be here to talk about the draft in a minute. But you were sort of starting down this road of we've got TCP, SCTP, UDP, UDP Lite now, where that been applied this sort of three-pass mechanism. There's a bunch of other protocols in the main document which we have not applied it to. So it seems reasonable to me that we start looking for people to try to, particularly people who wrote the sections for the first document, to try to do this pass on the on generating sort of this common structure of how we're describing the transport features. So I'm kind of putting that out there. My view as a chair of the group is that I think we should start doing that. which means that I'm asking you guys to do some work. What do you think about that? People who wrote sections in the first document, or who know about, let's see, I'm not going to be able to rattle these off, but we've got DCCP, we've got ICMP, we've got the multicast protocols. Are any of the people who wrote those sections in the room? I don't. No, I guess not. Are you nodding your head? Yes, I'll do it, Miria. Is that? Did I see that? No. Okay. Yeah. Just.
Thomas Eckert. I'd say that let's for the multicast part, I'd like to see first on the API side with UDP that we make some progress there, and then I think we can see it makes sense to expand into the more reliable multicast protocols from the API side. Because jumping into that immediately is just a possible, really big pain point if we can't get to agreements on the, let's say, UDP multicast API side.
Any other discussion on this? Is there a listing somewhere of who wrote what sections for the first document?
The contributor section of the first draft basically has a bisection listing of the people who wrote the sections. So the sections that Gori, Miria, and I wrote are not listed in the contributor section, but you can just do that by subtraction.
Okay. All right. Well, I guess probably the thing to do is to probe the list a little bit, since many of those people aren't in the room. Let's see. So we have one implementation project we're going to hear about today. I'm wondering whether anybody else here is aware of other implementation projects. There are folks who are seriously thinking about implementation, planning implementation, want to implement. So we can get some discussion. One is great. Two is much, much better.
So, hi, Brian Trammell, ETH Zurich, no hats. We have the beginnings of the thought of an implementation of something that might be an alternate API that could have taps as a backend. We call it post sockets. It's not cooked enough that we decided that we wanted to talk to people about it here yet.
Post sockets.
Post sockets, after sockets. Yeah, as we actually get some experience with how bad an idea that is, or we'd like to say how good an idea it is, but where the pitfalls are, then we will definitely bring that to the TAPS list, possibly to TAPS in Berlin. But there is active implementation work that goes faster the more students we can throw at it. But
okay, great. There's another slide. Oh, just do that myself. I've got a coach here. So revised schedule. We slipped a bit the convergence took a little longer, as I'm sure everybody here is aware. Our milestone, what we did was we took these, we're grouping the usage documents as an extension of the first milestone. So the document that we're getting ready to publish doesn't complete the milestone, which is why I'm pushing the date out. I don't think that we're going to get text for all the remaining protocols that we want to consider by the next IETF. So just doing some simple optimistic math, that says that we hope to finish up the milestone 1 documents by November. So I think that's doable, but it kind of depends on whether people are still engaged. And then, frankly, the rest of the stuff is just wishful thinking, because that's the sort of the researchy aspect of this activity, is that we don't really know where the hard parts are in the development. So this is just so you know, we'll be updating the tracker to reflect these. Does that mean that these people are waiting to speak, or that they're just tuned in? They should. Yeah. Thank you. Okay. Okay, good. Just want to include people. Blue sheets are going around. If you have a blue sheet, can you raise your hand? Is there one on the other side? They're both there. Okay. Is anybody not signed the blue sheets yet? Goes to the back of the room, straight back. Okay. So, go back to the agenda. Naeem, come on up. Let me get your slide up. I might. I think this is yours. Do you want to advance them? Oops. Full screen? Yeah, I'll get that. Okay.
Okay. So today I'm providing an update on the TAPS transports usage draft, or document 1A. So basically a very quick update, and after that I would like to hear from the working group about the discussion items. Next, please. Okay.
All right. Try and read.
Keyboard is identified.
I think it. All right. We'll do it. You'll
Should be all right. Yeah. So now this document is a working group item. Its name has changed from the Wetzel TAPS transports to the IETF TAPS transports usage. So we now have a terminology section in the document that is compliant with the terminology of the IETF TAPS transports document. We have an appendix in the document explaining how to contribute to the document, which means that this systematic three-pass process is being explained there. Another appendix lists the RFCs that are so far being used to compose the document, so that we have a list of them and know what is being included and what is not. We had some comments from Gori, various comments, mostly minor comments that are being addressed. We had some comments from Karen that are being addressed. So this is the status as it is being updated right now. Next, please. So the plan for the future is to incorporate more of the CTP-related RFCs. Currently, the document only includes the RFC 4960. So the plan is to, for example, include the RFC 6458 in the draft, as well as other RFCs that might be related. But also another item is to include the MPTCP, UDP, UDP Lite. These two basically comes from Gori. DCCP and DTLS. So we have potential contributors for all of these protocols, and this is going to happen hopefully in the next IETF, that we will have updates on those. This includes updating, incorporating the Fairhorse TAPS transports usage UDP draft into the document, and finding a right way of merging these two perhaps, or incorporating them. Next, please. And so with regards to the DTLS or TLS, DTLS, the section 3.7 of the TAPS transports draft mentions that the DTLS does provide security functions, but the API basically comes from somewhere else. And in the current way that our document is, the rules that are mentioned in the Appendix B basically prohibit us using any stuff that comes from outside IETF. So the question that, because none of us of the authors are very expert on the TLS, DTLS, so the question that we have for the working group here that we would like to put on discussion is that what do we do now? Can we, for example, just run the OpenSSL or any other package over a TAP system and ignore the details of these packages for the document, or we need to do anything else? And that's something that I would like to bring to discussion here, if anybody has an idea. Somebody must have some idea.
Do you have anybody who knows about TLS? TLS. Anybody know about TLS? Anybody? Anybody? Rich?
Yes, please.
Michael Tüxen. Are you asking about exposing the OpenSSL API, or?
Sorry, I don't.
I mean, you're asking, can we just run OpenSSL over a TAP system? are you asking for this from an API perspective or from an implementation perspective, or are you looking into what kind of API OpenSSL provides and exposes to its users, or?
Just take it with you. So mostly for the purpose of the document is that we need to specify an API, how to use the TLS and DTLS. And this API basically mostly comes from outside the IETF documents. So what do we do now? That's my question. Should we?
So one possibility would be to specify the OpenSSL API in an
Yes.
internet draft.
Yes.
That's what you are.
This is one of the possibilities.
Okay.
Generitema for Microsoft. I mean, we do have implementation of DTLS at Microsoft, and they do not use the OpenSSL API. I am a bit skeptical about the general idea of doing standardization of more than the abstract API in the IETF. Because, I mean, the concrete APIs, especially in the case of security, they have a large part of stuff like key management and certificate management and basically intent that depends on management functions that are very system specific. So I really wonder, I mean, if we go to standardizing the TLS, for example, why would you pick OpenSSL rather than the S channel or Boring SSL or LibreSSL or whichever? And that's really, I mean, I am really skeptical about having the concrete API done in the IETF when the actual API depends on programming languages and depend on management functions. And that's even more so for security APIs.
I think it's a really good point. Let's make sure that gets into the minutes.
Rich Saul Zakamai, although I'm on the OpenSSL dev team. Yeah, if anything, at most you want to put it in an informative appendix on how you do the bindings, but I think documenting the properties you need in the security considerations or otherwise is the place to go. I think having the bindings would be interesting, but certainly not part of any kind of other official thing.
Hi, Brian Trammell, actually +1 to both Rich and Christian. Quick question, so to somebody who has a little bit more experience with the TLS documents than I do, is there a useful abstract API that came out of TLS? I don't think there was. No, okay. So I think probably the right thing to do here is to define a minimal abstract API for TLS in this document.
Because the working group, because we're better than the TLS working group.
No, not in terms of what the thing can do, but in terms of the services that we need, right? So I mean, like there's just a few. It's like, here's a thing, please encrypt it. Here's a thing, please decrypt it. Here's a little. Here's some cryptographic magic. Here's some configuration knobs. We're not going to actually worry about what those are, right? Because all of the stuff that makes TLS hard is the details of what those are. But from the standpoint of the transport, you just need to have some way that you can pass through understanding what those things are, and I think that might be possible. I'm not sure it's, yeah, obviously there's the second thing, because we're a working group and we're really good at hitting our milestones. And this is an excellent way to ensure that we don't hit our milestones. But I think from the transport side of things, the bits of the abstract API that you need for something that looks like TLS are not that big. I haven't actually sketched it out to convince myself that I'm wrong yet there, but I think that's the right thing to do.
Thomas Eckert. So the interpretation of the rules in that Appendix B or so, you know, if the RFCs are incomplete to what we need to define, then we can either create a shitty job and be compliant with that appendix, or we can figure out what the best way is to create a useful job. I think it gets even harder to basic protocol than just, things where the API clearly is outside the RFC space. I was sending yesterday an email with respect to kind of even simple aspects of the API, like, what's a transport endpoint, right? And those things have in, these, 30-year-old RFCs on TCP and UDP not really well been specified, especially in UDP. There's a lot more variety, and I haven't even started on the multicast part of that. So, I mean, those are things that, if we want to create even a, usable abstract API, there is some leeway that we need to have to go beyond the RFCs, or else we'll just, create as bad an outcome as what we did 30 years ago when we first wrote those RFCs.
Just to belabor the previous point, Christian Wittmer from Microsoft. I'll give two examples of things that are done in security APIs that are hard to put in abstract. One example is the management of your certificate route. I mean, how do you decide which certification authorities you will accept a certificate from? And that kind of stuff is really a management function. It's seldom done with the transport API itself. It's done some other thing, yet it's critical for the operation. Another example is whether you want to ensure that the encryption keys that you are using are protected in hardware or merely copied in software. I mean, this is also a fairly important function because it decides whether some attacker taking a dump of your memory can get the keys or not. That kind of stuff is extremely hard to specify in an abstract way without looking at what system you're working on. And you won't do it the same way in, say, a phone and a server.
So, Christian, before you go away, let me just, and question, I guess, for the room, one option here is we just punt on DTLS. Do you have an opinion on that? We don't include it?
Yeah, well, I don't know whether Martin Thompson published a draft a month ago, 2 months ago, describing how to map quick over DTLS, which is, I would say, a concrete application of the composition structure that we're describing here. And the interesting part there is that the solution that Martin proposes is based on layering.
Just on layering.
Okay, having a layer of UDP and then DTLS layered on top of it, and then having the quick transport function layered on top of DTLS. Now, I do not know whether Martin's proposal is what will actually be accepted and implemented, etc. But it's fairly legitimate to look at this layering approach as one way of doing composition. So, and DTLS appears to be one of the basic block you could use in this layering. Yes, there's some interest in DTLS, definitely.
Mayor Kuhlemann, I would just like to mention a different protocol, and that's called TCP Inc. And we have in the TCP Inc. working group a document that proposes an extended API. It's currently an individual draft, but we will discuss the adoption of the document as a working group document this week, and so maybe that's also something to look at.
Okay.
Mirror shorter than me. I'm Gori Fairhurst. What do we do is the question I'd like to try and answer.
Yes.
I suggest we carry on with this draft and refine it, and the way I chose to approach the UDP thing was to write a separate draft, just to try and get enough people behind it to see if actually that made sense. That could be even better a strategy perhaps for the DTLS, not necessarily to publish a separate RFC, but to create an internet draft that tries to bring the security stuff together and see if it can be done. Because if people can't make any sense of that when security people read it, then that probably indicates what the working group should do. An option.
So are you suggesting that we should separate the security part from the rest of the draft and have it in another draft? Or
DTLS.
I'm suggesting that you find people who know about this
okay,
and are interested and encourage them to start writing a draft following the same format as this and see if it can be done for the security stuff. And if they succeed in writing one, get security people to then look at this and see if it's useful before you start integrating this into a bigger document where things get confused. We did that with the first TAPS working group document, and we managed to get everything together and build an encyclopedia. But then it's very difficult to get critical review on individual parts. So you have to turn fast on this, because otherwise the process becomes extremely long. But if people are interested in writing a quick draft, then you can easily see if it can make sense.
that sounds reasonable to me. So I think that's basically what we can try. But do we have enough people or any people who would be interested in doing that? I mean, at least in the audience here.
So Amy, it looks to me like there were, given the people the microphone, there might be collaborators.
Okay.
If you were willing to hold the pen for the main doc, maybe if you held the pen for this other doc, that you would find that other people were willing to tell you when you got it wrong,
Okay.
which the IETF is really good at.
Okay. Yeah, we can try that.
So you say you don't feel like you could start it?
Well, not with the security part. I mean, we would be looking for volunteers, so we would prefer to stay in the main document. I mean, I would be more of my involvement would be on the main document. So
Right.
we would be looking for contributors for this, basically the second one.
Right. Okay. I think we're in agreement. I thought that Gory's point is a good one. That initiating these things in separate documents makes them easier to work on and get collaboration on and get review on by subject matter experts. And my experience in the IETF is it's the sort of fine tuning where you can lose an enormous amount of time, and the longer the document gets, the harder it is to get people to look at it.
Exactly.
So if we can get these things done in small chunks and then pull them into the larger document, I think that might allow us to move faster and in parallel. But we need somebody to start it.
Exactly.
And it sounds like you're willing to do that.
I can try to initiate it, or at least pull the mailing list and see if anybody is interested. But I think we can take it to the mailing list and find the contributors. I'm not sure if everybody expert in the security or TLS, DTLS will be here. Or, I mean, some might be here, some might be.
Right, but the people who aren't here don't understand what we're trying to accomplish, which is why sort of the initial structure and sort of a straw man it'll be hard to explain to them what we want.
Yep, that we can try to do. Yes.
Hi, Rick Sauls. It's probably worth trying to get to the TLS session and ask for 5 minutes just to explain it.
You want to try doing that?
Yeah.
I think, well, I thought the suggestion of, there were two suggestions. One was Quick had done the layering. And what was the other suggestion of somebody who'd done, I thought it was Corey mentioned.
The other example, Christian Ritema, the other example of layering is WebRTC, which use things like DCTP over DTLS over UDP.
Yeah.
Just a concrete example of layering.
So I think we can find somebody who's involved in one of those other efforts that they already have the abstraction in their head, and it's a matter of just fitting into our format.
Yep.
Maybe our area director could help us.
Yeah, maybe Utah is the better working group to go to and talk to the people.
Which group?
Utah?
U-turn.
Yeah, UTA.
UTA.
Yeah.
Are you taking lessons from Ecker on microphone handling? Because I've noticed that it's getting faster Each IETF. You have more to say. I appreciate that. UTA. Okay. Okay. I think if you can push forward the creation of the document, we can help find collaborators, between the folks
Okay,
looking at the microphone.
sure. I can try to ask for that DTLS.
And UTA. I don't
Yeah,
know
and
when they're
UTA,
meeting, but
Yeah, I
we
have
can
to check it.
figure that out for one.
Okay.
Thank you. Okay, next is Corey. If you like. Wow. But you didn't share it with anybody else.
I have. Well, I could share it with Dispatch. I thought it would be easier for them. Okay. Here, this works. Okay. Okay, I'm Gori first again. I'm going to talk about the individual draft on UDP and UDP Lite. I presented a one-slide version of this talk in Dispatch a few minutes ago to try and encourage other people to read it. It maybe gives a little bit of a hint as to the problems we face in TAPS. After all, UDP is probably the simplest protocol you can ever think of. It of course, is a well-defined API sometime in the dark ages, which we can't quite remember anymore. And therefore, everything describing the way you use UDP is scattered along a whole range of drafts, which became RFCs, were published, and promptly being archived in various places. My draft follows the same methodology as outlined by Neem and Michael. So don't shoot me on the methodology, shoot them. The idea is that the text in this draft can go straight into their draft as soon as other people think this is a good description of how UDP works. It's a three-stage process. Because stages 2 and 3 mainly focus on integrating together the different parts, we focus mainly on stage 1 in the draft. Okay, here's the additional picture. These are the things I think you need to call to use UDP from looking through all the RFCs that mention something like a UDP API or UDP control functions. It's quite simple. You send and receive things. You may or may not be connected, which brings a whole wealth of options to how you actually send and receive, but hopefully we get that simple as we go through the TAPS abstraction process. There's then a whole load of primitives which, because it's UDP, are exposed right to the application, and the application has to provide handlers to know how to deal with them. Things like deciding the checks on coverage appropriate to the app that's using it, if you're using UDP Lite, whether you accept a zero checksum or not, how you do path MTU discovery, because that is up to the app using UDP, not UDP itself. And then a whole lot of network functions which would be nicely abstracted away, except on a UDP interface, you can send and change these per packet per datagram because they all might be going to different places and they all might be of different types. So we end up with a lot of things exposed. All of these were defined in different RFCs, so we've so far taken nothing from outside the RFC series. The big question at the end will be, is there something missing, of course? This is the version for the TAPS working group, rather than the pictorial one for Dispatch. Same set of functions. We focused on the connected mode for UDP because that most clearly can be combined with TCP and SCTP semantics in the future as we think about TAPS unifying these. If people use UDP, hopefully many people use UDP, if people write applications to UDP, please look at our draft and see whether we've covered the right sort of things for the applications, for the way you program, so that we're including all the good stuff. The more tricky bit is the UDP options. This is a difficult mic to coordinate with. It's not too bad for basic unicast transmission. Multicast has become a bit of a rat hole over the years because we've had different multicast frameworks and we've had service models of ASM and SSM. We've ended up with IGMP v3 and MLD v2, and therefore we ended up with a whole load of source-specific extra paraphernalia. So we ended up with a very large number of multicast-related primitives, which you might want to call if you had a UDP application supporting multicast. So that list is all in appendix. We did one rev. We did a rev 01 because we forgot about something. There is an option in UDP to require a checksum at the receiver. As TSVWG co-chair, I should have realized this because I keep telling people that it's important for some applications. Anyway, we added that, and we added a normative reference to the UDP guidelines, which seemed very appropriate for this rather than an informative one. So the tour was relatively short because if you're interested in this, I really encourage you to read the draft. It's much more important to go through the checklist and check that we've found all the things you expect to find in a UDP interface than it is for me to present on something which should in theory be trivial but isn't in practice. So I have some questions. I have more questions than this, don't I? The first question is this what is needed by the TAPS working group? If people have read it, is this the right sort of document to consider combining with the other one? Or I could just take questions on the whole thing, whatever Thomas.
No, I think I posted my comments yesterday, and so for example, this whole accept and listen and all the parameters needed for that's kind of as unspecific as it is in random RFCs, right? So it's fairly useless. And if you give this to somebody who hasn't seen a socket API and try to see if he even comes close in doing something which is a workable socket API, he wouldn't be, right? So that's the problem, that the reference material that you have to start from is, in my opinion, pretty useless on the API side, right? So how are we dealing with this, right? I was trying to express how I think the socket APIs, see, I mean, the RFCs were just writing down what people felt needed to be done for bloody interoperability, right? So, I mean, the fact that the APIs are sucking, especially the older the RFCs get, I think we knew that from the beginning. So I think we'll have to be really careful on using that as the only, religious reference from which we define the services. And then that multicast stuff, yeah, sure, you've got the list of all these wonderful things that we did, including SSM, and that stuff is all sucky because that we didn't want to have IGMP v3 in the first place for SSM, and it was just there, so we took it, and then basically the API was also just an extension of another, 1994 API. So I mean, this is just crappy, but it is maybe exactly what TAPS wants. It's just not very useful.
I think the multicast thing in particular is fairly well messed up, so we have to figure that out as a separate question as to what we do with multicast. I don't know my pushback on the whole socket API thing. I'm wanting to hear other people talk about this because UDP isn't really well specified. So where do we get specification from?
Michael Tuxen, can you go to back to your one of the first slides where you had this lovely picture of the API?
Yeah, this one.
You were asking if there's missing something.
Yeah.
I'm wondering if some access to ICMP messages is missing.
Which I think is called error report in Michael's taxonomy of how things are separated. So under the error report thing, we assume that a connected socket allows you to get ICMP messages back for UDP.
Okay.
There is actually something missing there, Christian Mitema. Especially that's used a lot in the case of multicast usage, and that's the notion of reusing ports.
SO reuse and all that.
Yes. Which is kind of mandatory if you want to do multicast, because
for the multicast bit, absolutely.
You can have.
Is that only multicast?
It's not only multicast, but it's definitely mandatory when you use multicast.
Yeah, I'm aware of it in multicast. Okay.
The suggestion I have is that do we, I know what the answer will be. But, did someone do an analysis of how these APIs are exposed in practice in different programming environments?
Did somebody look at this?
Yes.
Yeah, and Tom Jones is programming to BSD in Linux and a couple of other.
Because
Less interesting
there are different dimensions there.
Yeah.
Is one dimension is whether you're running on BSD or System 5 or Windows NT or something like that. And there's another dimension, which is whether you're running in a sandboxed API or not. Like the Windows apps or the Apple's apps or things like that, which have their own things. And then there's yet another dimension, which is what programming language you use. Because, I mean, it doesn't quite look the same in C++ and in Java or C# or higher level APIs. So it might be interesting to do this kind of comparison, because if we are delving into doing abstraction of APIs, I mean, looking at what abstraction already are there, and in fact, the more, the higher, when you go to the more expressive languages, or the more abstract languages, the more abstract you get different things. For example, a classic feature of the more abstract languages is that you will use names instead of addresses.
Yes.
And things of that nature will be less.
Okay. I don't have a problem with what you're saying. I'm not quite sure what to do. And the reason I don't know what to do is because when you cut it like this across the different APIs, you also have very different use cases for UDP that cuts the other way.
Yeah.
So you have servers that respond, you have servers that don't bind because they accept from anywhere, ones that do bind because they only are point-to-point. It's
a big space. That's what I was telling you, I mean, in private, but in practice, when you develop applications that you want to port in many different environments, you end up doing some kind of a shim API for your own purposes. But the reason you can do that shim API is precisely because of this vertical slice that you're mentioning. Because when you're doing your application, you know exactly which service you're going to use. So you define that shim API for those services, and then you have a fighting chance of mapping them the various environments in which you port your application. As for the mapping everything in a single shim is kind of an oxymoron.
Again, I can say yes. I don't know how to progress quickly.
Yeah.
Tommy Polly Apple.
Sorry, what was your name again?
Tommy Polly from Apple. So partially just in response to some of the practical points you made about like reuse port and stuff. So like we do have one of those high level UDP APIs, Objective-C and all that stuff. If you are doing a more connected oriented UDP, like we don't expose like a reuse port because we do it like just implicitly, you just always reuse port. And so some of your stuff did seem to be more like, we'll have a connect on this so you can receive ICMP. So maybe that can simplify things. You don't need all the complexity of some of the normal socket layer reuse port logic. Also, one thing I was wondering on here, you get interface MTU. I don't know if maybe that's too restrictive to an interface-based scenario and assuming what's beneath you. You kind of expose like a similar flavor of it, but like just like maximum datagram size. So it doesn't really matter what you're running over, but within UDP headers, how much room do you have? I don't know what your thoughts are.
Yeah, I think the names here I tried to take from various RFCs.
Yep.
And I think as we abstract away, I think the maximum datagram size is much more like, say, DCCP did, which is a little bit higher in terms of its understanding of how this is. So maybe
it makes it just more generic in a way.
Yeah, it's more generic and it's probably more useful because there are systems out there that do PathMTU discovery support for you.
Right.
So you can actually get something better than
Right,
actually
better than just having to minus header sizes.
Yeah. Yeah, well, with VPNs and stuff running underneath, you actually understand what they are.
Right, exactly.
So for the connection setup, so because you said you just covered the connected model, where's the slide showing what the seek? Because that was kind of from the draft really hard to understand.
Which,
Right, so it's connect for the client and accept for the server. Is that the idea?
this is the model that we have at the moment.
Okay.
And we have to figure out whether that model really works.
Yeah, I mean, I think it works for the connected model, right? I think there are parameters missing, right? Especially around, the port. And, well, usually you try to get a port that is free, or you try to get a port that you want to use.
Yes.
And then the IETF has, in the meantime, come up with these ephemeral port ranges and things. And so, for example, should there be something in there saying that you want to have a particular port with a semantic in it, right?
Yes.
Because, that isn't clear right now, right? So, because you don't want to kind of, let me put that logic, which we actually have in IETFs on top of the API, let's sequentially try to do a connect with a local port, right? So.
Okay, so we could try and express something about how you use the port space. Because, there's symmetric ports in UDP as well, because some signaling protocols expect you to have send and receive ports the same.
Right, but then also usually you'd say, I want to have a port in the ephemeral range, and then you need to, of course, learn on return from the API call what port you got. Because you may need to put that into ICE signaling or something like that, right? So there's a lot more details on that side. There's also the extended socket API things in IPv6, which have some implications like, changes on the default for doing path MPU discovery for multicast, like don't. Right, so there are things different for V6 than before if we go back to the IETF references. And then last but not least, I think one of the key things about UDP is that we must have the not connected API option, right? So I think that's quite important.
Okay, I think I got that.
Michael Wessel, in the interest of progress with this group, I'm wondering if the questions that have been raised regarding changing these primitives a little bit and diverging from what is in the RFCs wouldn't actually be something that could be of interest for the second document rather than the first, where we are going to make a recommendation about what the TAPS system should exhibit, whereas that is supposed to be just a list of what exists. This could be a more efficient way of handling it, maybe.
On this, I don't want to comment. We have to look at the process here. But I do think that the stuff we've heard probably should be embodied somewhere in this draft. If it just comes appendix or whatever, just so that we don't lose it. But whether we really start fleshing out stuff that's new to the RFC series probably isn't a good idea. So I think we shouldn't be trying to embellish it too much, but we need to keep in mind the way people are really using it in other RFCs that build upon UDP.
I agree.
Okay, multicast is the bit I didn't actually have a formal question about. Multicast is something that doesn't concern most of the other transports we're looking at here, but it does concern UDP Lite and UDP. Are we going to spend time in the working group trying to expand upon the multicast parts and build this up into a body of work, or are we going to kind of park on it and say, well, we'll deal with unicast first? We had a little bit of this in the charter discussion, but I don't know where we got.
Well, I think where we got was we said we were not explicitly preventing any coverage of multicast, but we were going to put our priority on point-to-point communication. So if we would allow this stuff, but I think that, I'm concerned about, the enormous complexity of trying to pull in APIs for multicast, given the challenge that we have just for unicast. So I would be okay with sort of making the observation that these things exist, but not trying to be as comprehensive as for the other stuff. But I think that it's really kind of where the energy for the group lies.
Yeah, so hi, I'm Brian Trammell, and my theme this morning seems to be just suggesting that other people do enormous amounts of work, so I'm going to continue with that theme. I would say really that, so there's a really interesting insight in the fact that almost all of the complexity in this document is about dealing with the complexity in previous ways of doing multicast. And I think one of the outputs of this document could be somebody should go fix APIs for doing multicast and fix the group management stuff for doing multicast and then come back and do it.
That sounds like a great charter for another working group.
It does. So I was going to make the same observation that, yeah, we went back and forth on this in the charter discussion a little bit, and we said, okay, well, we don't want to end up going completely down a rat hole. And on trying to make this work in multicast in all the situations that it would. And I think that this document is a very interesting sort of bit of soundings into that rat hole. So we know kind of how deep it is, and we know sort of the shape of it. And maybe we should put some cones up around it and say, don't step in this rat hole. So I like the fact that the document does it, and the document should say that, but maybe there should be some commentary, maybe in an appendix or something that says, by the way, we know that this is kind of, and because of that, we're going to defer further work in this area.
Yes and no, because if you were to abstract this stuff away, it's not actually as messy as it looks.
Okay.
So the messiness is at this level. When you start scanning the RFCs and you're figuring out, oh, MLDV2 did it this way, and RGMPv3 added these functions, and then there was a source filter, blah, 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 you end up with a whole pile of stuff. In practice, I suspect some people already have libraries around this, which make it a bit easier. So
it would be interesting to go look at those, actually.
What do you mean, we, Kimosabi?
So I think it should certainly be possible in number 3 to simplify the APIs by just taking the one with the most parameters and have that as the only one, because there are a lot which are just simplifications, right? There's an IPv4 only API which existed for history. There's one that doesn't do a particular option, right? So basically those are all simplifications by simply, leaving out a few parameters from a generic API. So the whole options of APIs I don't like, but I think that if we just stick as one simple part in number 3 with coming up, a generalized API that is just one API for the multicast join, right? That has all the parameters. That looks simple enough. Is it good? No, but it's at least better than, listing all the 10 options that we have in the SSM API, right? That would be the SSM API, all these 10 options, I think, are part number 1. Maybe in part number 2, part number 3 would just say, okay, there's one superset. That's very simple.
Turles, you're the only person who stood up and asserted that this is work that should be done. So looking around the room for people who are potential candidates to do it, you are at the front of the line. Are you willing to write something?
I think within the scope of what TAPS has, which is I think the only thing I'm always complaining about, Gore already did a great job, and I think I can certainly help to simplify that stuff. It would certainly be interesting to see what other things can be done, right? So first of all, I think when it comes to just other datagram protocols, unreliable datagram, well, is implied by the word datagram, but I think they have all the same multicast APIs, right? So I mean, there are a couple of alternatives to UDP that have gone through the IETF. If you folks are interested to put that into this or the merge draft, I don't think there will be differences on the multicast side. And then if we feel that there is basically some better multicast API to propose, I guess that sounded like we shouldn't take that into the current TAPS document, but maybe finding another place to put that in and put a reference in, like.
Yeah, I think that the exclusion of multicast was really sort of a practical consideration to try to make sure that we actually got to the end of the charter for some set of stuff, and I think that, but we didn't want to exclusively carve it out in case that there was some low-hanging fruit or people who wanted to work on it. So, or we could recharter later to go back and add to it. Your comment about sort of non-UDP datagram protocols, the step 2, the phase 2 in the charter is about taking a subset of the protocols identified in phase 1 and saying this is the useful common subset that we want to build some TAPS mechanisms around. And so I don't know if it's worth the effort to go and pull in things that aren't widely used if we're going to just throw them out in the next step.
No, I would say that and I haven't even looked into these alternatives for UDP that have been done later in the IETF, right? The only reasons why they might be interesting is because they're newer than UDP, so maybe when it comes to the basic API specifications, they provide some more useful references than UDP, right? Otherwise,
can you give an example, an alternative to UDP?
I'm trying to remember what one of the names was.
Okay, well, we can take it offline. It's not
So I just need to figure out what I'm doing next.
So, just from structurally, I like the idea of having an individual draft that gets, that matures, and then the content will get pulled into a working group document. So I would say, keep on working on the existing draft. Sounds like Tros wants to help with some multicast stuff. Do you have open questions? Is there work that you think needs to be done on the document? Are you done for the stuff the scope that you covered?
I think we feel we're done for the scope we covered. I think we feel there are some open issues about whether you bind and have connected sockets or not, and how you might use those sockets. But do I have more wisdom at the moment on how to write that and what should be written? I don't have.
You need help.
So I'd need help. Or we could merge this with Michael's draft as soon as we hear back from Ted Hardy and a few people in dispatch about whether we've missed something fundamental. So
is there somebody who can help with the sockets question who's got some expertise on that? What we need is technical advice.
Or we merge. We take the inputs we come from we could take the inputs we have been offered from dispatch, which is just general review of the document, and then we could merge it with Michael's document and keep this as a thing we work on. We'd happily continue to work with the merged text if that was useful.
Any objections to that proposal?
Do you need to know if people are ready, or are you just happy with it now?
I'm happy with it. I thought it was a fine document, but it
So-
seems like it could maybe, it hasn't had a lot of review, so well, there has been some discussion.
Okay, so what the authors plan to do, I'll speak for Tom and I, is we will keep this open and revise it, and before we get to the next IETF meeting, we will formally offer the text to be merged with Michael's document as the working group contribution on UDP.
Sounds good. Stein? There you are. Oh. Okay. Okay. Now they're both. That wasn't really what I was going. I can
Okay, thank you. So this is about work item 2 in the TAPS charter. And the outcome of this would finally be the document that is a subset of transport services that we want to expose to the user or the application that uses TAPS. Next slide. So this is an overview of the draft. I will first explain this shortly. Will go into some more details, and I will end up also with this draft or this figure, so we can discuss about it. So this is the TAPS system, and these are the IETF transport protocols. So these are the usage drafts are here defining all the transport protocol services. But the charter says we are going to make a smaller interface at the top here. It should be a minimal set, and it should be an abstract interface. So the task is to take all the transport services and find out who are we going to expose to the application using TAPS. And all of this is of course up to discussion, but I think the right part of the figure is more questionable, and we have more questions to the right part than to the left part. Because for all the application-specific features, there must be a subset that we can almost directly export up to the TAPS application or the application using TAPS. And we have, because we are going to give guidelines on how the system should use this this interface, we have divided the application-specific features into functional and optimizing. The functional are what the application really needs to know in order to work. The optimizing features are the one that is nice to know because you can optimize your communication by using those. So that's the left part. The right part are the ones that mostly are going to disappear from the user, but maybe some will be found in a slightly different version, because we might want to combine some of these IETF protocol services into other interface calls up at the top here. So they are then, some of them are automatable, and some of them are used in another version. So some are deleted from the application view, and some are combined into new interface calls. And then there might be some features that are completely automated. That's what we can call under the hood usage. So maybe a TAP system can automate some of this, and then they will be deleted from the app view. And maybe also some of the features are not seen or used by the application at all, because we are going to define a minimal set. So in order to get a smaller set, of course, we have to completely delete some features. So I'll go through some examples of this, and then we can come back to this figure in order to discuss it. So next, please. So as I said already, we have the two groups, the potentially automatable, that are the ones that are not viewed by the TAPS application in the version that they currently have, or they can be application specific. So I guess I already said that. Next. And the application specific features is divided into the functional ones that the application has to use this, or if not, they will lead to incorrect operations. But you also can have some optimizing features that if the application uses them correctly, they will improve the performance. Next. Okay, so in order to make a minimal set and maybe to automate some of the usage, we have added some features, or we think there should be added some features. We have to discuss this, of course, so that some of the features of the IETF protocols can be more or better viewed by the user or used by users. That's the added features. And the deleted features are, of course, those that are not going to be exposed to the user, TAPS user, or are going to be exposed in another way because they are automatable or added in some other form. Next. Okay, so in the current draft, we have only used the first usage document, which contains TCP and SCTP. So for TCP and SCTP, we have found 15 functional features, 7 optimizing features, and 16 features that are potentially automatable. And in this first draft, we have suggested that we add 3 interface calls or 3 features, and we have deleted 8 features. Okay, next. So some examples of these features. The functional features examples are, for example, listen, reliable send, or close. You need to use these in order to have a working system. Optimizing is Nagel's algorithm, or change diff-cert code point. And potentially automatable are specifying IP options, for example, listen N and notify unsent messages. And then we have suggest that we add, for example, connect, listen, and notify send. And we add listen because listen comes in different forms. Listen one, listen N, listen all. So we think there is just need for one listen. That would be a simplification. So we have deleted then, for example, listen N, and we have deleted specify IP options, and we have deleted notify unsent messages, because then we can instead use notified, just notified send failures as a simplified interface. It simplifies API call. Yeah, I think that was all. Next, yeah, so we come back to this figure, and my question to you is then, is this a good way forward? I mean, in the charter, item 2 is to define this interface on top here. The final point in the charter is to define how to implement it, of course. But the question to you is this a good way to give guidance, to structure the document, and of course we have to maybe the hardest part is to find out what should we automate or add on the top here so that it can be used in another form than it's currently in the IETF transport protocols and the usage document. And can some of this be really automated so it's not seen by the user at all? And what should we completely delete because we don't want to use it in the minimal set? Yeah, I think that's my presentation. Questions?
Gary Fairhurst again. Oh, louder at this side. Stein, you can guess what I'm going to ask. When we do the UDP integration, you'll end up with things like be able to set the DF bit on an IP packet, which never really was a function of the TCP or SCTP APIs because they do that in the PathMG discovery. That's kind of been built into the whole protocol framework. And yet it gets exposed up to the app because it's the app that does PathMG discovery in UDP if we do that. And that's going to be a theme, I guess, with all the other little parameters that I discovered for UDP is they get pushed upwards for a datagram service because there's no handler in the transport layer. Is this okay, or should we somehow separate out datagram from connection-oriented, or do we have a feeling about how to approach this problem of having to expose a whole lot of stuff just because the datagram side needs it, whereas the other people don't?
Yes. I mean, good question. I, of course, I don't know. I mean, it depends on how complex, how complex you wanted this abstract interface that we're making.
Oh, I want the abstract interface simple. I want the abstract interface simple.
Simple.
Yeah.
Yeah. So maybe then you will not be allowed to do this for UDP. I don't know.
But then UDP would be broken, so you won't be able to use it.
So,
Okay, so no, it's just I'm trying to think ahead because these are the sort of things which are going to hit us. We do need a simple abstract API, or else we're not doing something good for everybody.
Maybe you can automate that.
Well, you see, if we automate it, then we provide a protocol machine above UDP and below that abstract API. Do we do some protocol work here or somewhere in the IETF to make that new module?
Isn't that what automate means?
Huh?
Isn't that what automate means?
Mm. And maybe there's interest in other working groups to pick up on this who actually know about the particular mechanisms and can just do it.
Yeah, so, all right, I have a confession to make. I didn't read your draft. I don't know, it didn't get into my pile. I only just realized it. It's like, why is this so unfamiliar? But I think that just based on the discussion, I don't think there's enough meat on it yet to really understand, for me to have an opinion as to what might be missing or whether the direction might be wrong. So I guess based on that, I'd say keep going, and eventually I'll have an opinion. And I think that just sort of given the lack of discussion here, maybe other people feel the same way. It's pretty abstract, and it's not until you start to get into some specifics that people can say, oh, that's not going to work for me. Tommy?
Tommy Pauly, Apple. Yeah, to that point, yeah, I think that trying to apply this to some of the practical scenarios does help a lot. Like in the UDP case, you know, okay, there's this extra option. So I think maybe one response to that is saying, I think we do need the ability to say, okay, don't fragment is an option that is very relevant to some protocols. It should be, some people, part of the top level abstraction. I'm not sure you can automate all of the way. You can maybe choose a default. So maybe is there a category? I'm not sure if it's not really optimizing, but it's almost like an optional functional. Like depending on which protocol you're in, it's like, it's not one of the core functionals, but because you could probably get your UDP thing working without ever worrying about this option. It has some sensible default that most people use. However, you may need this. So maybe there's a third category, or maybe other categories that we'll discover as we try to apply it to
Yes.
UDP and others.
I completely agree, and I think maybe some of these application-specific features, both of them, could have a default version, but then if you want to change it, you need something on top here to change it.
Right, which adds to the complexity of the top level, maybe in optional ones, but maybe the minimal subset is still simple.
Absolutely. So you can have a minimal subset, but then you can have an optional extra, or not an optional, but an extra subset that you don't have to use.
Right. You only use one if relevant.
Exactly. Yeah.
So Björn Falk again. So it's interesting that your view on what you're minimizing, I think, is different than mine was, and I don't know whether whether I'm the one who's outside what the group thinks or whether you are, but I thought we were taking of the existing transport protocols, we were taking the minimum set of protocols to represent in the abstract API, and it looks like what you're doing is taking the minimum set of features that you can expose through the abstract API. And I frankly think that if when you add, as you add each new protocol here, you'll find that you'll be able to delete fewer and fewer things, and that you're not going to have the difference between the number of calls at the bottom layer and the number of calls at the top layer is not going to be that big, because your API's got to support so many different protocols, and there's only so much that you can automate or throw out. But I think that the reason that we wanted to talk about the minimum set for this phase of the work was that we wanted to get to the point where we could do some prototyping of mechanisms to select from these things without trying to come up with mechanisms that would handle all the transport protocols that we described in the first document. So
but
maybe I'm crazy here.
There is just one minimal set in the TAPS charter, so you cannot make a first minimal set and then later another minimal set.
I agree, but it seems like you're trying really hard to throw out unneeded stuff that you don't want to propagate up to the top layer. Mm-hmm. And I actually don't think that that's the major value of this stage of the working group. It's more, let's pick what set of protocols that we identified in the first phase that we want to apply this approach to. So I thought that this phase 2 was actually going to be short and possibly trivial. It's basically a decision-making step saying, we're only going to pick, 5 of the 15 protocols that we described in the first document, and we're going to build an abstract API for those. And then we move on to phase 3, where people actually get to build something.
Yeah, but then you don't, in phase 3, you don't build more than you specify in phase 2.
Correct.
So so the result, if you do that minimal set, could be that we get a TAPS RPA that cannot be used because it uses so few of the protocols.
Yeah, so that's why I think that's the I don't think TAPS needs to be the universal abstract API for the transport layer. I think TAPS, what TAPS produces will be useful if it picks like a useful set of protocols that it can abstract from underneath. I don't think it has to be all the protocols.
Okay. Yeah.
I mean, the working group differs. That's okay. I'm really just giving my opinion, but this was my understanding when we were developing the charter. So, if folks disagree, then they should speak up.
And if you're looking for more meat, there's a little more meat in the draft.
Yeah,
I mean,
I should read the draft.
Yeah. Okay.
I'd feel a lot better if somebody else said they agreed or disagreed with me. Slowly.
Mia Kulevin. I'm not sure if I can agree or disagree with you. In step 3, we should definitely have a smaller set that we actually want to implement and provide.
Smaller set of
protocols to support. In this step, we have to make the decision what to support, but we should probably still have in mind how would it look like if we would like to support all protocols, so it's possible to extend the API later on easily without redoing it completely.
Within reason. No disagreement, but I'm concerned that could become an enormous project if you try to include everything.
I agree here.
David Lawrence, I agree with you. It was my understanding as well that TAPS was to provide this basic, like if an application developer just wanted to be able to say, look, all I want to do is get data from here to there. What is the minimal set of things that I need to enable in order to do that, and let the operating system or whatever layer pick the best protocol to enable the core functionality that I need? Then that's where TAPS has a lot of value, simplifying things.
I hope that helps you, Stein.
Yeah.
Okay.
Yeah, well, yes. Okay. We'll make a new draft but we would like to also people please read the draft and come and give us input. And,
I'm not saying that this is not useful effort.
No,
I think
no,
this is very useful.
Yes,
but
yes,
I think
okay.
that, if you're trying so hard to remove stuff,
Okay, but what I take away from this is that most of you want a very, very minimal set, so there might be a lot of good features that cannot be used by the TAPS program.
I didn't hear that.
Oh, okay.
Gory first again. Let's see if I can try a different flavor on this. I think we do have to reduce the number of protocols we look at, or perhaps the number of protocol modes for things that have many flavors to the same protocol. So we just get a set of things to work from. I think we need a simple abstract API. But the last bit you said, I think I disagree with, which is it prevents you doing things. It may be that these become non-default options, which you can then elaborate in TAPS using the API. So you can do things that the simple set doesn't. The simple set lets you do things very simply. You build a very simple app, but I think there's a danger that the app then becomes a little bit trivial. And if you try and port a real application over, you maybe want to be able to influence some of these things with some particular protocols. So you have non-default ways of influencing that, which are, you can specify, but TAPS somehow takes care of it. That was my hope. Maybe that's different, but I don't know.
So means that the complete set of API is quite big, but you only have to use a small part of it in order to get some real benefit.
Yeah, so your program could be quite simple in the way it uses the API, And then as you engineer your program, you can specify non-defaults if you have to, because you discover that with this particular protocol, you have to do something. And maybe it's all a group of protocols that have to do something. So simple to use at the first place, but a little bit extensible so you're not working in a very limited sense.
Well, the API cannot be extensible, but it can be a lot of features that
The features I'm talking about, yes. I'm not talking about new versions of the API or evolving the API. I'm talking about specifying extra parameters to make things work.
Yeah. If you are interested in using special features, yes. Yes.
Tommy Polly, Apple. Yeah, I think we should distinguish between a small and simple API and a small set of features, because depending on the way you design your higher level abstraction of the API, there are things that show up as individual toggles you have to do at the low socket level today, which may become easier to do or just kind of get wrapped up into your higher level functionalities. So, for example, like reading and writing are clearly functional things that we need to do on our connection. Depending on the way you do it, for example, if you have like a asynchronous model of reading and writing that kind of gives you more feedback in the basic minimal subset, there's certain pieces of functionality that have to do with how, today you have to do pacing via socket options on a TCP socket that now could get kind of wrapped up into your basic read and write call. So it's still a simple API, but depending on the way you use it, patterns that you do in the timing, that could actually influence how that translates into a much broader subset of functional pieces below. So we shouldn't necessarily say, oh, these features are just going to have to get kicked out because they seem like they're going to be too complex.
Yeah, so I feel like maybe we've lost a little bit of the original focus of where the working group is trying to go. That my sense of the great value that was going to come out of TAPS was to apply the happy eyeballs approach to transport protocols. And to be able to do that, you need to be able to abstract the what the application is asking for to the level that you can actually trade off various transport protocol feature combinations to see what works. So you can give the best thing that works, and but you can down select to still give some connectivity if it's not available. So to me, that's the goal of the TAPS API should be to expose a set of services that can be composed using existing protocols underneath. And so when I think of what that API should be, it should be simple to the set that you can actually ask for something where you could I can get it using SCTP, or I could get it using TCP, or maybe I can get it using UDP with something else. And the magic of TAPS, or the benefit of TAPS, is the automation that does the probing to see what works and then combines and sets up those features. And so, because I don't think that in terms of like helping programmers build applications on IETF protocols, a single protocol, I don't think we've got much to add here. I think that people are building libraries and OS vendors, they have that expertise and they bring that value, and that's not, and we shouldn't be trying to solve that problem. What we're trying to solve is the problem of how do we express what these protocols are doing in a way that will allow them to be swapped in and out based on what works end to end. So I see the analysis of what's going on here is like, okay, well, how do we have, so we went through in phase one and we picked out these sort of common features from different protocols. And now we can say, oh, okay, well, he wants reliable message transport. Okay, I've got 3 protocols that can do this. So I need to expose an application that I expose an API that allows an application to say, I want reliable stream transport with enough specificity that you can rule out some of the things that are actually going to work for the application, and you don't try to provision a service that won't work for them.
Yeah.
Okay.
Equivalent, I agree. And I think this little bit of magic you've been talking about, and you used the word, I didn't, is all in this box called automated. So because like the other part where you have the basic functionality, that's kind of straightforward, but in the right part, it's a little bit, it's not clear what to do. And for me, it's a little bit abstract because I don't really know what's in this box happening in this box. So I would actually like to talk a little more about functionality we can provide in this box, and then talk about the interface afterwards.
You talked about setting IP options as an example of something that happens in the automated box, but I didn't really understand what you meant by that. Like, what would an application ask for that you would automate? You know, yeah. What's that box going to do to set IP options?
I don't think I said you can automate it, but
Oh, okay.
maybe. All right.
Potentially automated.
Yeah. Because you instead specify our token. We have deleted that from. Okay. Maybe my coder can answer that.
Okay, Michael Wessel. I didn't come here to answer questions. I'm not sure if I can. What exactly is the?
Never mind.
We can take that offline later. Yeah.
Okay. So I'm getting pretty confused by this discussion, and it might be me, or it might be that people didn't read the draft.
Well, not alone.
Yeah. So I wonder how many people here have read the draft. This presentation is a bit high level, right? So
4,
okay.
5.
Well, there are some. So the reason I say I'm confused is that I agree with everything that Aaron said about what the value of the group is and what the goals here are, and what Miria said, she agrees, and it seems that everybody agrees on that. I thought that the point of doing what we're doing is to identify mainly the functional mechanisms, because these functional features are things that well, if you don't expose them, then you don't have this choice of picking STTP, for instance, or TCP or whatever. Right? So I didn't see any other way of approaching that rather than saying, okay, we need to identify what is functional such that we can make a choice and pick a protocol. And so then we can start classifying them into things that, well, if you want them, you can provide them as well or not. But this is, I tried, I'm not clear, I don't quite understand the difference between what we're doing and what you're proposing.
Maybe there is no difference. I was responding to
that's what
the
I believe.
presentation.
Yeah. Okay. Well, just not sure.
I'll go read the draft. Send comments to the list.
Okay.
Mia Kuhlewend again. So for me, the difference is that in the draft, I don't see the mechanisms to, for example, doing an automatic fallback to TCP. If you're trying your protocol and then you fall back to TCP, you need to do some measurements and stuff, and you need a mechanism for it. And I would like to see how this mechanism looks like before I make a decision on the interface. And in this automated box, we also don't need to stuff everything that would be possible in there. We could actually decide which mechanisms we want to go for and then just concentrate on those. That was okay for Michael.
Okay. Thank you. Now we're going to meet.
Yeah, this is about not about the NEAT project completely, but about a piece of software we are writing within this NEAT project. So I will give you a very short description of who is part of NEAT. So it's not my work I'm presenting, but it's the work of the consortium. And then we'll give you an overview of an implementation of an abstract, of an unified API for accessing transport protocols, and actually walk through the API and through an example to show you how an application looks like when you write using this API. So this is the partners of the consortium, and also a link to the website of the NEAT project. And also the last one, or of the GitHub project, so that the software we are building there, the Neat library, is an open source library, and we do everything there on GitHub. We opened it a couple of weeks ago, I think 2 weeks or so. Yeah, here's a disclaimer. This is work in progress. So this API can change anytime in a substantial way. So we start doing things, exploring things, making experiments, and add things, change things. We have something which is working, but you should not rely on this. This is also not tested very much. But if you try it and if you use it, we are happy to get reports, bug reports, comments, whatever you want. And we have this disclaimer necessary for EU projects. So, the library we are writing is BSD licensed, so you can use it in products. You don't have to open source your product. This is a pretty, I mean, we wanted to allow people to use this stuff in products. It's implemented in C. The question came up here about if you do something, which kind of programming language do you use? We decided to use a pretty basic one, C, and then you can add language bindings to your favorite programming language to this, if you want to, but we are just mapping to the socket API layer, and so we decided to use C. We think it's portable, and we have done kind of porting to various versions of, or incarnations of Linux, of Unix. So we are running on Linux, on BSD, FreeBSD, NetBSD, Mac OS X. We haven't done a Windows port, but it should be possible. I mean, we think it would be possible. You have to map to the slightly different socket API provided by Windows, but it is possible, it's just not done. We also only support transport protocols which are currently available in the kernel of the operating system we are running on. So if you're running on Linux and FreeBSD, we support currently TCP and SCTP. On NetBSD and Mac OS X, we support TCP as long as you don't have loaded an NKE for SCTP. The plan is to include a userland stack for SCTP so that you can also have SCTP support on platforms where it is not natively provided by the operating system. So the architecture should allow this. We are using a callback-based API, so this was one of the high-level decisions we had to make. So it's basically you get called when a packet comes, when a user message is available or something like that. And we are using also libuv to get this kind of stuff for the sockets you normally use on the operating system. When we are using this, we are talking not about a TCP connection or a UDP, whatever you call that connection. We are talking about flows. And since the application might not have specified which transport protocol it uses, so a flow might correspond to an SCTP association or a TCP connection or whatever you have for UDP and UDP-like. So when I said currently we only support SCTP and TCP, this means there's ongoing work to also support UDP and UDP-Lite, but it's not there yet. But the idea is also to support all these 4 protocols when provided by the operating system. And we also need to have a way to specify when we want to set up a flow, where do we want to talk to, and we call this a name, and the name is a DNS name which gets resolved, or a list of IP addresses. So you can have a list of IPv4 and v6 IP addresses, and then you resolve these strings to numeric values and deal with that. So we have not looked into supporting other naming schemes, but it should be possible if you have something else. So we go through the API. I actually go through neat.h, something you would include in your code. And well, since whenever you use a library, you have some initialization stuff, and what you do here is you get a context. So a context is consists of all the information you have, which is not applicable to a particular flow, but is valid for more than a flow. So initially, you need to initiate a context, and you can free a context. So you free it at the end, you create it at the beginning. That's pretty simple. And since we are running in an event loop, you have explicit control on this. So you have to start at some point the event loop, and then only callbacks get called. So we have a function called need start event loop and need stop event loop, which starts the event loop and stops the event loop. And you provide a context for that so that this works out. So I told you we have callbacks. So this is this current set of callbacks we have. We have an unconnected callback, which is called when currently when a transport connection gets established. So for TCP and SCTP, we have this concept of connection oriented in the transport protocol. We call it there. For UDP and UDP Lite, we haven't looked into that, but I guess what is true is that you will get an unconnected callback before you get the first, there is something readable. So you might not realize that a transport connection has been established, but you get this before you get the first message. And when walking through the code of the example, you will see that you need this before. We have an on error. This means whenever something goes wrong, an error is called, and you get an indication what went wrong, so with an error code. We have unreadable and unwritable. Unreadable means you can read something, whatever that means. We will see that later. You have to explicitly call read in this callback if you actually want to do the read operation. And you have unwritable, which means you can write. So in this callback, you can write a message, so send a message or whatever. And we have also a callback unwritten all, which means when I write a message, I have a buffer where the data is in, and I pass it to the library, and you should not free this memory until the need library has completely finished processing of it. And this is exactly the callback you get where you can do this. So we try to avoid that you have to do extra buffering when using this library. So you pass, the application passes a buffer to it, gets a notification when it's done with a buffer, and then can free it. Yes, so you saw the parameter of all these callbacks are flow operations, and you get a pointer to the flow, a pointer to the context, and all the other callbacks. So you can play with the callbacks during the callbacks. And there's also a function how you set these callbacks. So you write these callbacks, put them in a structure, and say, for this flow, I want these callbacks to be used. For the flows, you can create one and you can free one. This is something you would expect. Before you do actually some data transfer or initiation of the communication, you want to set some properties. And we will see this in the example that you first create the flow and then you set some parameters and then you trigger a call, say, now do something with it. And this is how you actually make sure that something happens on the wire. So you can call need open. This is, for TCP, it would be connect. So you can say, I have a context, I have a flow, I have a name, and I have a port number. Please establish a communication with that peer. This is what need open triggers. And then a couple of stuff happens, what we will see later. You also have accept. So on the passive side, so need open is on the active side, need accept is on the passive side. And we have to figure out a way what this means for UDP and UDP Lite, but it will happen before you get the first data. So you can trigger this on receiving the first data message. And there is a need shutdown. This corresponds to the TCP shutdown call, which means I don't have anything to send anymore, but the flow should not be terminated. So this means on connection-oriented protocols, I don't want to send anything anymore, but I want to still be able to receive something. This is important if you implement some applications. So now coming to the flow properties, and this is where we have right now a very basic setup, and during the next 2 years of the project we will explore that more. Some of the properties is what kind of network protocol will we use. So is it IPv4 or IPv6? And while thinking about what kind of control do we give to the application, the basic thing we now provide is a way to say we want to ban this, so don't use this, or you must use this. So you can say you must use IPv4, or you must not use IPv6, or you say nothing. And if you don't say anything regarding that, this means IPv4 and IPv6 are candidates, and the NEAT library will figure out what works and what doesn't work and what should be used. So you can influence that. The same way you can talk about transport protocols. So you can, if you write a specific HTTP server, you can say, I require a HTTP. Or if you just have something you want to, like a discard server for everything, then you just say, don't say anything, so everything is allowed. You can also say, I want to be congestion controlled. This is something normally an application has to provide if the transport layer doesn't provide it. So you would say, I want congestion control, or I don't want this. And also retransmissions. I mean, retransmissions means reliability. Currently, we can only say we want to be reliable or not. This gives another hint. As you see, you can do combinations which don't work. So you can say, I want reliable transfer and I require UDP. Then we just return an error. So there are combinations that don't work together, but normally you expect that the application gives some freedom to the library to make a choice. We can also deal with security, at least in the API. This is not implemented, but we can say that there must be security, or we want it only, and it would be acceptable if the negotiation figures out that security is not available. And the same is there for message boundary preservation. So an application can say, I want to send messages and I want that message boundaries are preserved, and then it will happen. And yeah, so these properties are currently actually bitmaps, so you can OR them together and use NEAT get property and NEAT set property to deal with them. So it's not NEAT open and NEAT read, it's NEAT write and NEAT read. So you have read and write operations to do I/O, and if you are using, if you have required message boundary preservation, then you have atomic writes. So what you provide in a NEAT write call is considered a message and is transferred to the other end and delivered there in a single read operation. So in case of HTTP, where you have to do, and sometimes you have to do reassembly in the application layer to assist HTTP, this is done within the NEAT library. So you don't see this as a user. You can send a gigabyte message to the peer, and it will appear there as a gigabyte message. Going to an example, so you can go to the GitHub repo and find a subdirectory samples, and you will find there a client and a couple of servers like daytime server, discard server, something boring like that, but you can figure out if your API is working. And this is how a typical server looks like. I actually took the source code, removed all the variables, removed the command line option processing, removed error case handling, such that you see what is the sequence of function calls you have to do. So as you would expect, the first thing is you do initialize the context, initialize the flow, and then you have a property. You can say, I want to be message oriented. So you would say the property is need property message, and then you set this property. Then you set two callbacks. You have to define a function which is being called when a connection happens or an error happens. You set these operations. You call need accept with a local name. A star means any address available on this host, port 8080, and you start the event loop. The good thing here is I can tell you this without telling you what the server does. This is very generic. So connection handling, the unconnected call does nothing but sets callbacks. So it sets a callback on all written and on readable, which means now we are, the need library knows what to do when something is readable, and it will, when something is readable, it will call the unreadable callback. The unwritable call, I mean, the callbacks for all on all written, it means you can read again. So actually what we do is when we read, we do something, and when we have processed everything, then we are ready to process the next incoming request. So then we set unreadable again. In unwritable, we write this stuff and say unwritable is null. So when we have something to write, we write it, say we don't write anymore until something else happens. And this something else is typically that everything is written out completely, and then we do something again. Now comes the interesting part, the handling of the input. So when we are able to read something, we actually read it with a need read call, and we get back, we provide a buffer and we get back how many bytes we read. And if this is larger than 0, which means we got some messages, then we say we don't want to read anymore. So we say that the unreadable callback is null, and the unwritable callback is now set to unwritable. So this means once we have read something, we say we don't read anymore, now we want to write. And if buffer filled is 0, which means the connection has been terminated, we just say all the callbacks to 0 to null and free the flow. This is a typical way. So this actually is the code of an echo server. It receives a message, sends it back, and once it's sent back, it receives the next one. So how does a client look like? I mean, the handling of unreadable, unwritable does not depend on the role of being a client or a server. This depends on what kind of service you are realizing with your application. What here is, that's why I'm only showing you the main function of the client, because that's different. It starts with the same thing. Basically, you say initialize the context, you initialize the flow. This time, the client says, I want retransmissions. So I want a reliable transport feature. And it sets the flow, it says unconnected, on error, sets the operations, and calls need open. And then starts the event loop. That's all it does. Everything else is done by the need library and then by calling the callbacks. So the question is, what happens when you call need open? And what happens is need open looks at the properties. And in this case, the properties, the only property which was set was I want retransmissions. And it looks what kind of transport protocols does this operating system provide. So I assume we are on Linux or FreeBSD. It will be SCTP and TCP. You might have IPv4 and IPv6. So you have two network layers and you have two transport layers, 4 combinations. And it will do a name resolution, figure out whom should we talk to. And if this peer has also a lot of addresses, maybe B4, maybe B6, it builds all combinations and has then a set of candidates it can use to talk to the peer. And it will basically start all these, it will basically try all these combinations to figure out what is working. So it can end up with TCP over IPv4 is working, or SCTP over IPv6 is working, or any kind of things. The result of this happy eyeballs process will be used, of course, but it also will also be stored. So it might be that we do the happy eyeballs and figure out TCP is working, and we figure that out first. But we also started testing if SCTP is working, and find later that we figure out that TCP is working, we figure out that SCTP is working too. So we saw that. So if the next time we have to talk to the same peer, and we have to make the same choice, and for whatever reason we want to prefer SCTP, we have an indication that this is working, and we might want to try this or wait a bit longer or whatever. So we are not only testing this stuff to do the actual communication we want to establish, but we also cache the results of what was working for future connections. And we not only do this for which transport protocol is working, but the plan is also to do this for what was the parameter like RTT, like what was the quality of service, what was the packet loss, what was the possible bandwidth we have. And if the application provides requirements which can influence the choice based on that, we will use that. So the current status is that we have the basic connectivity and basic working, communication working. These higher layer information and these more abstract requirements the application can formulate, that processing, that's something we want to do in the future. So figuring out what an application can say, like, I have a bulk transfer of that amount of data, or I have real-time data, or whatever, and how this influences the candidate selection. So that was an overview about the API, which we currently support. It's open source. You can try it. We would be happy to receive comments if we have done a right choice of the API, or if we are missing something, whatever. So we are open for feedback. The GitHub page is there. You can file issues, comment there. You can try it, compile it, let us know. Any questions?
I have a question. What are the next steps in your development?
The next step in the development is UDP Lite integration, that we get non-connection oriented transport protocols in and see if that fits. Integration of SSL and TLS and DTLS. It will be part of it. So as far as I know, it will not be implemented on top of the Need API, but inside the Need library, and then DTLS will just provide a message-oriented service with encryption, or TLS over TCP, or a byte stream in a secure way. Integration of the userland stack, and that's the basic stuff. And then the more abstract one, where you have more abstract ways of defining the requirements of your protocol choice.
Nacho Solis, Park. I don't know how much time you want to spend talking about software and apps, but number one, do you think has to do with switching from IO?
So we used libuv because we needed something, we took it. And as far as I understand the stuff, we will also provide a way that if you want to use a different event loop, you can do that. You can use libuv. The plan is that you can use. The plan is that you can use the need library with an event loop not being libuv.
So you would integrate with whatever in C event loops, libuv or libevent or something or other.
As far as I know, you can integrate this libuv stuff into other event loops.
And so the first question was if you could comment on the difference of the separation, if it matters at all, of the fact of the work that we're doing at TAPS and abstracting the communication with the integration within a synchronous event system versus us doing, let's say, TCP sockets over an asynchronous type of event loop and not having the blocking and wait stuff. So part of the different, maybe it's integrated into what TAPS is the way we view the network and the API to the network. And the fact that we're using an event loop here versus just having simple blocking and non-blocking calls will be different. Because you could have implemented this with the blocking and unblocking calls.
Sure.
Right.
So we had to make a choice. So we did it this way because we thought that's most appropriate for people to use this library. I'm not saying that TAPS should make a statement on is it blocking or non-blocking API, but we try to follow the TAPS API in a way that we provide a way from abstracting you to specify the exact transport protocol you want to use.
Right. No, I was not.
So that's the connectivity to TAPS.
You know, I was wondering if you wanted to make a statement or not by choosing an asynchronous. If you don't, that's fine.
No,
I was just...
we wanted to support one thing, and we thought that this is the most appropriate way for potential users of the library.
Yeah, I can also see a lot of things where I worry whether they should be, mentioned in TAPS or not, but the synchronous versus asynchronous, I think, is definitely, a local choice of a concrete API as opposed to the abstract that we want to go with TAPS. So I wouldn't bother here in TAPS about that, but I think the conclusion was simply that the more complex programs needed anyhow. Once we do something in userland like HTTP over UDP, we'll need some, threading in the background that handles the protocol events, and it's a lot easier to put a simple, synchronous API on top of an asynchronous one than the other way around. So those were a few of the reasons why we chose the more generic asynchronous approach.
Again, not just, I didn't mean to criticize. We have a transport stack that does exactly the same thing, mostly because of those reasons where we need to have our own control loop. So if we were implementing our own transport on user space, then we would need to have our own thread, and the event loop would allow us to do an abstraction. It just gets tricky when you try to integrate with sockets and the own select loop of the application and whatever.
Did you say you're implementing TAPS? You said you had a project that was doing something like this.
We do, but we do not use IP. So
don't use IP.
No, we do not.
What are you doing?
So there's a IC Energy research group on Thursday where we have our own transport, I should say layer 3-ish protocol, and that can run on top of right now overlay IP. But in our protocol, what we have is we have a modular stack where you can select, and currently I've used the word, the features that the transport layer provides, and we have this exact same problem. And things that we do is reliability, like we do here, and whether we want to do stuff in order, because we don't have to deliver things. We have messaging, we have security built in, so we do communication to the stack, and the stack can be configured, but we end up with the same exact problem, right, of having to figure out how to communicate. We use libevent, but it's still a pain because we make choices and you end up trading off. Anyway.
Yeah. Great, thank you.
We approve.
Any other questions for Michael? Okay, well, thank you, Michael. That was very interesting. So that's the end of our agenda. Does anybody have anything else that they would like to raise for discussion before we close the meeting? We switched slots at the last minute, and they gave us a somewhat larger slot than we needed, so we got some extra time. But y'all can go back to doing your email. No reason to keep the meeting going. Is there anybody in the room who's not signed the blue sheets? Raise your hand. Is there anybody in the room who has the blue sheets? Okay, please, opposite side of the aisle, please pass it back. Okay, so, thank you to those minute takers, and we're adjourned. What'd you